Hi everyone, today our topic is forming linear equations to solve problems. So now that we know how to actually solve an equation that someone gives us, we can now look at a word problem and create our own linear equation and then solve that. So now we're using equations to actually solve a problem. Here are the basic 6 steps on how to basically read a word problem and figure out how to create your own equation. Make sure that this is in your notebook. So step 1, we read the question carefully and identify the unknown quantity. So there's going to be something that you need to figure out. You first need to identify and figure out what that is. Step 2, you are going to use a letter to represent that unknown quantity. So for example, x, but you get to pick that variable. Step 3, you're going to express other quantities in terms of x. So you're going to read the problem and figure out how everything is related to your variable. Step 4, you're going to use that information and you're going to create or form an equation based on that information. Step 5, then you can solve the equation you created. And step 6, write down the answer statement. So reread the problem, make sure you're actually answering what the question is asking you to answer. Okay, so be sure that these 6 steps are in your notebook, and then we're going to go over some examples following those steps. Here is the first example, example 13 from your book. The sum of 3 consecutive integers is 111. Find the integers. Okay, so we're going to follow our steps. Remember, the first step is to read the problem and identify what your missing or unknown variable is. So they want us to find the integers. Okay, so let's assign the integers a variable. We have 3 integers, okay, and we know that we need to find the sum of them, and they are consecutive integers. All right, so let's make the integers a. Let's make them a, b, and c. Okay, so we have 3 numbers, so we'll say a is the first number. We'll say b is the second number. And we'll say c is the third number. Okay. You know what? Let me get rid of 1, 2, and 3 because I don't want that to be confused with actual numbers. So let me actually say first number and second number, because we're talking about so many numbers, we don't want to actually have numbers in there, and third number. Okay, so we've only done that so far. We know we need to find the integers, the numbers that are missing. So we've assigned them each a variable, a, b, and c. Okay, let's reread the problem and figure out what the important information is. We already figured out that there are 3 numbers. That's how we came up with our 3 variables. And let's see, the sum of 3 consecutive integers is 111. So sum is an important word. Consecutive is also important, and then obviously 111 has to be somewhere in our equation. So if you reach back into your knowledge, you'll know that sum is just a fancy word for adding. So we know we need to add those 3 numbers together, a plus b plus c, to get 111. Well, you're probably looking at it and thinking, okay, that doesn't get me anywhere. There's 3 variables. I can't work with 3 variables. So far, I've only worked with 1 variable. I have A, B, and C missing. So that must mean that consecutive is very important. Consecutive means that they go in order. So you're going to want to write that down in your notebook because this word, consecutive, occurs all the time. I'm going to go ahead and erase that part so you can actually write down that vocabulary word. Consecutive means numbers that go in order. So for example, let's say 5, 6, and 7. They go in order. Um, let's say 52, 53, and 54. Those are also consecutive integers, okay? -3, -2, -1 are also consecutive integers. So any integers that go in order, they're just one away from each other, okay? So very important, they're only one away from each other. I just have to add one to get to the next number. Same over here. I just have to add one. They're only one away from each other. All right? So that information is going to help us figure out the relationship between the first, second, and third number. So instead of writing a plus b plus c, what we could figure out, let's use 5, 6, and 7 as an example. 5, 6, and 7. Obviously, the answers are not 5, 6, and 7 because 5 plus 6 plus 7 is not 111. Okay, remember the first number was a. So let's pretend 5 is a. How could we not use b and c because we don't want so many unknown variables? How can we just use a to figure out the variable for 6? Well, 6 is just one more than 5. Right? So instead of writing b, we could just put that 6 is, the second number is just a plus 1. It's just one more than the first number, right? So instead of creating more variables like b and c, we could just substitute with information from a. So if, again, 5 is a, then 6 would be a plus 1, just one more than a. And then, of course, 7 would just be a plus 2 because it's just 2 more than the first number because they all go up by 1. Okay? So now, instead of writing a plus b plus c equals 111, we're like, hey, let's make our lives easier. We can just have a plus 1 plus a plus 2. So a is the first number. A plus 1 is the second number, and a plus 2 is the third number instead of b and c. And then that is set equal to 111. Then, and again, this is an example, the 5, 6, and 7, then we just have one variable and we can solve it. Because remember, our next step now would be to solve it. So let me solve this. Let's remember that the first step is to deal with any distribution. These are just parentheses that I put there. I don't have to have those parentheses there. They were just to show you that those were grouped together. Okay? So they don't actually exist there. So we don't actually do anything with these parentheses. Okay, so I can go ahead and erase them. Ooh, smallest eraser possible. I can go ahead and just erase them. It's not an actual distribution problem. Okay, so then my next step, since there's no distribution, as you remember, would just be to combine any like terms I see on the same side. So that means I probably should draw my line down where I see my equal sign. So anything on the left-hand side that I can combine. Well, I have A and A and A. So in total, I have 1, 2, 3 A's. I combined all the like terms that had the variable of A. Let's see, I also have some constants, some numbers on the left-hand side. I have a plus 1 and a plus 2. Together, that would be a plus 3. And that's it. Then I've dealt with all my like terms. 111 stays the same. And then let's see, what's happening with A here? Well, first step was it multiplied by 3. Let me use this space over here. My first step was I multiplied by 3, and then my second step was I added 3. Lots of 3's going on, but let's go ahead and write down the steps. So first, my A multiplied by 3. Then I added 3. So going in reverse order, I'm going to deal with step 2 first. Instead of adding 3, I'm going to subtract 3 from both sides. Then I'm going to deal with the multiply by 3 next. Instead of multiplying by 3, I'm going to divide by 3. So my first step is subtract 3 on both sides. Okay, then I get 3a equals 111 minus 3. Let's see, that would be minus 3 is 108. Okay, and then my last step would be to divide by 3, both sides. Those cancel, so I end up with a equals 108 divided by 3. I get 36. Okay, 36. So that means that my first number would be 36. Because remember, a represents your first number. Now, does that mean that that's my answer and I'm all done? No, remember the last step is to reread the problem and figure out what they're actually asking you. They want you to find the integers, so all 3 integers. So I have 36. Remember, they are 3 consecutive integers, 37 and 38. That should be my final answer. Let's check. Does 36 plus 37 plus 38 equal 111? Yes, it does. So then I know that is my final answer. 36, 37, 38. The answer is not 36 by itself. 36, 37, 38 would be all the integers. Okay, let's try another problem then. This one says Mrs. Lee is 3 times as old as her daughter. In 5 years' time, the sum of their ages will be 62 years. Find the daughter's present age. Okay, so remember, first step is to figure out what our variables are. What is missing here? Well, we know the question is to find the daughter's present age. So we can make that into a variable because we literally don't know what that is. D, let's make it into D. D is daughter's, and that's a present age. So how old she is now. Let's be very clear when we're labeling daughter's present age because we are talking about later in 5 years. So it's very important we make D her current age, how old she is now. Okay. We don't know her mom, Mrs. Lee's age. We could make M equal to mom's current age. But as we know from the previous problem, we don't want more than one variable. We just want one, right? We either want D or M. So I'm actually going to get rid of that because I already know I just want one variable. So let's just keep one variable, D. D equals daughter's present age. All right, so we have the variable. Let's reread the problem for some important information so that we can start making our equation. Mrs. Lee is 3 times as old as her daughter. Okay, so let's pretend that Mrs. Lee is M, mom. So mom is 3 times as old as her daughter. Okay. So whatever her daughter's present age is, you just multiply her mom's age by 3, or sorry, her daughter's age by 3 to get her mom's age because it's 3 times. Times means to multiply. And we can just write it as 3D. Okay, next piece of information. Again, we don't want this M, so let's see how we can get rid of it at the end. In 5 years' time, so in 5 years, that means everybody will be 5 years older, right? So in 5 years' time means everyone's going to add 5. The sum of their ages will be 62 years. Okay, so then that means we're adding the daughter's age in 5 years plus the mom's age in 5 years. And the sum is going to be 62 years because sum means to add. That's how we know we got to add. So let's figure out daughter first. If the daughter is D, then in 5 years, it would just be D plus 5. Okay? So that's daughter's age in 5 years. Okay? Because D was just daughter's present age, how old she is now. So in 5 years, it would just be D plus 5. Okay, so we got to add to mom's age in 5 years. And remember, we don't want to use M or anything. We want to try and use D. So we know something's going to add 5 because it's in 5 years. But what is mom's current age right now? What do we add to 5? Well, we know that Mrs. Lee is 3 times as old as her daughter. So instead of M plus 5, because we don't want an extra variable, we can just put in 3D because her mom's age is 3 times her daughter's age anyways, right? So those two will be added together to equal 62 because daughter's age in 5 years is D plus 5. Mom's age in 5 years would be 3D plus 5 because mom is 3 times as old as her daughter anyways, so 3D plus 5 will get her age in 5 years. The sum of their ages, the addition, will equal to 62. So that's how we got that equation. Okay, we're using the information from the problem. I can erase all this because this was just helping me figure out my addition. I also don't need these boxes. It was just for me to figure out what's being added together. So I can rewrite this without my boxes. I don't need any parentheses. And there's that. Okay, so there's no distribution to solve. Now we're solving our equation. Let's see if we can combine any like terms. Well, I do have a D here and a 3D here. So they need to be added and they become 4D. And then I have a 5 plus 5 and a plus 5. Those two can be combined. They're like terms. They're both constants. Plus 5 and plus 5 is plus 10 equals 62. And now we have a two-step equation. So we need to figure out what the variable D, what operations it went through. First, it multiplied by 4. Then it added 10. So going in reverse, the second step becomes the first step becomes the second step. Instead of adding 10, we're subtracting 10. Instead of multiplying by 4, we're dividing by 4. So first step is to subtract 10, both sides, because we want to keep those equations balanced. Those cancel out. 4D equals 62 minus 10 is 52. And then our second step is to divide by 4, both sides. Those cancel because I have 4 on top, 4 on bottom. D equals, let's see, 52 divided by 4 is 13. So D equals 13. Is that our final answer though? Let's reread the problem. Find the daughter's present age. Daughter's present age was D, we said. D equals 13. So yeah, that is actually our final answer. The daughter is 13 years old. Okay. Let's try one last problem. This problem says the price of a table is $100 less than 6 times the price of a chair. A similar set of 1 table and 4 chairs is priced at $1,400. Find the price of a chair. Go ahead and pause this video and try it on your own first. All right, so let's go through our steps. First step is to read the problem, look for our missing information. We already read the problem. Looks like our missing information is the price of the chair. So let's make C equal to the price of the chair. I actually don't like using Y or X because it's much easier to remember the C is the price of the chair. C stands for chair, right? The only times I would want to use X, Y, and Z is if it's to avoid a variable I don't want to use. Like I don't want to use S because my S's can sometimes look like my 5s. Sometimes I also don't want to use T because if I forget to do the little curve on the bottom, it look like a plus sign. So just things like that. And Z I like to avoid as well because it can look like my 2s unless I put a line through it. But in general, whatever the word starts with, you can use that as your variable. It makes sense. Okay, so we set our variable up. C equals the price of the chair. It's very important you write price of the chair because sometimes problems might talk about number of chairs or prices of chairs, so be as precise as possible so you don't mix it up and give a different information. Okay, let's reread the problem so we can start setting up our equation. The price of a table is $100 less than 6 times the price of a chair. Okay, let's make T equal to the price of a table. Okay, and remember at the end we don't actually want to use T because we just want one variable. So, but let's just use it to kind of set it up. So if T is the price of a table, the price of a table is equals $100 less than 6 times the price of a chair. 6 times means 6 times the price of a chair, 6 times C or 6C. $100 less than that. So you should already know that less than is a tricky phrase. It means subtract, but you got to subtract it from your amount. So it's not 100 minus 6C, it's 6C minus 100. So you got to reverse that order. So the table is $100 less than 6 times the price of a chair, okay? A similar set of 1 table and 4 chairs is priced at $1,400. So let's set up that equation. 1 table and 4 chairs, so we got to add those together, is priced at, so that total bill, when we add it together, is $1,400. Okay. So far we have 2 variables though. We don't want that. So since we're trying to find the price of a chair, let's try to get rid of the T, price of table. How do we get rid of that? Well, instead of T here, let's replace it with this stuff, because they're the same anyways. A T is equal to 6C minus 100 anyways. So instead of writing T, let's just write 6C minus 100 instead. And then we're going to add it to 4C equals 1,400, okay? Because we don't want 2 variables, we just want 1. So instead of T, we're writing 6C minus 100, because a table is equal to $100 less than 6 times a chair's price anyways. So we can just write it over here. All right, and then again, we don't need this parentheses because it's not really showing distribution. It was just to block it off. And then let's solve. On the same side, are there any like terms? Yes, we have a 6C and we have a plus 4C. So in total, it's 10C. And then don't forget this minus 100, which can't be combined with anyone else on this side. So we just keep it as it is. Okay, so what happened to the C? Well, first it multiplied by 10. Then it subtracted 100. So going in reverse order, second step is going to be first step, and we're going to do the reverse. We're going to add 100 instead, and then divide by 10. So we're going to add 100 to both sides to balance it out. So we get 10C left over equals 1,500. Then we're going to divide both sides by 10. So C equals 150 after you divide those. So let's read the problem again. Find the price of a chair. Well, C equals the price of a chair, so the price of our chair is $150. That's your answer.